Всем привет! Hello, everybody! Меня зовут Алексей Акопян. Я сегодня на этом треке буду техническим экспертом, и поскольку наш гость из Норвегии, я перейду на английский. Hi, everybody! I'm now switching to English, and I would like to present Joep Piscaer, who is a great technologist, a consultant, founder, CTO, and many good things doer. He is going to speak today about why should we even bother considering switching to Kubernetes? What kind of problems people usually are trying to solve, and should they actually bother about these problems or maybe about something else? Hello, youth. Welcome to DevOps. How are you
Thanks.
doing today?
I'm doing good. Thanks for having me.
Do you feel the good atmosphere for the technology conference?
Oh yes, yes.
We
I
had a very nice technical check, which was positioning your picture and everything very precisely. Have you been in such conferences before when people are so diligent about placing you?
only one, but that's the conference that I run, and so I
Okay.
one of my clients hires me to help people do exactly this. Have good talks on the internet about cool technology stuffs.
Great, nice. I have a couple of questions if you don't mind. First of all, I know that TLA is not the any specific term. It's like a three characters word to draw attention, right?
Yes. Oh
But
yes.
yeah. Uh, but I actually have one thought. Just want to share it with you, because we are on DevOps related conference, and a lot of people are here working as an SREs. Looking at TLA as a name, I have a
Mhm.
feeling that it stands for Technology Level Agreement.
Oh, that's a nice one. No, it's honestly it is just a three-letter acronym. And that's it. It's nothing more than just a three-letter acronym. At some point, I had to give a name to my company, my consulting company, and I figured, okay, I can do a lot of cool things. I can, spend a lot of time thinking about a lot of difficult or really cool names. But in the end, I ended up with TLA just because I like having a three-letter acronym as my company name. So that's what my company is now called, three-letter acronym.
Oh, this is interesting. Not many people in this world actually like three-letter acronyms, and now we have at least one here.
Exactly.
Okay, another one small thing. The symbol of TLA,
Mhm.
is it a submarine or Zeppelin?
No, it's a Zeppelin. It's definitely
Okay.
a Zeppelin.
All right. Then, with all these introductions, I would like to proceed with your talk. Please go on. The stage is yours.
Thank you so much. All right. So let's begin with why Kubernetes isn't the answer, but what was the question again? So let me start by introducing myself. My name is Joep Piscaer. I live in the Netherlands. I do many things for many different clients. I'm an industry analyst, so I write about companies, I write about technology. I do developer relations, which means I organize events. I help developers figure out how to use certain pieces of technology. And then I also do technical marketing, which means figuring out how a product is, how it works and how to convey a message to a group of developers like yourself. I do that for my own company, TLA, but for many of my clients as well. So let's begin with kind of discussing why we're here. Because, we're here because of Kubernetes, of course, right? So we're going to talk about the why of Kubernetes, why we're here, and why everyone is talking about Kubernetes and specifically the technology, but also its potential. Because when I look at Kubernetes, I don't see just a piece of technology, I see a potential for an organization. but I don't see many people actually talking about the consequences of choosing Kubernetes, right? So, and I have a good example of why I think talking about its potential, but also the consequences is important. Like this self-operating napkin, for example. It's definitely a solution to something, but what problem it actually solves isn't super clear. It's just not very clear from a picture, right? And so even Gartner doesn't really know what the solution is. Literally, they say Kubernetes isn't always the answer, but they don't mention what the question is. Again, it's weird because we're now talking about a piece of technology that can do many things. And of course, I mean, it can do a lot of things. Um, but the key is, are we making technology choices the right way? Or maybe we're doing it wrong. So in my talk today, I want to help you figure out um, what the question is again. So we know the answer is Kubernetes, but what's the question again? So we're going to look at how we're making technology choices. Are they okay? Are they not okay? And just as a note, I'm not saying that Kubernetes is the wrong choice. I'm, in a lot of cases saying Kubernetes is a good choice, but not always, and not in every case, and not just like that. So I'm saying that the way we make these technology decisions is entirely based on technology and nothing else, right? I don't want to talk about how to change that. So, if we look at Kubernetes, it has a lot of potential, can do many things, but the most important thing is that it democratizes infrastructure for developers. It makes it easy to build and run containers from a developer perspective. It allows them to deploy their apps more easily, more often using declarative constructs, YAML, and it has a super large ecosystem of tools around it for CI/CD monitoring, observability, security, storage, you name it. But again, you shouldn't really look at that. Don't let the potential of Kubernetes and everything around it and the CNCF guide you, because the potential isn't real. Potential is unrealized success. It is hope, nothing more than just hope. And hope is postponed disappointment. So the burden of making overcomplicated technology connection choices is real. And the future disappointment of making the wrong choice is as well. So the problem is, if we don't know what business problems we're trying to solve, how do we even know how we're successful? And if we don't know that, we'll end up adopting technology for technology's sake. So we'll end up doing, Kubernetes because we do Kubernetes. But did we actually solve a business problem? Did we actually solve the right business problem? Who knows, right? So this animation kind of sums it up, and I hope we can show this on the video stream. So the falling person is Kubernetes. The leaves are an organization. And look at how long it takes before the organization starts moving and how chaotically. You can do so much with technology, but you would need to successfully adopt it first. So that requires changing the way your organization works in a lot of areas. So it's not just realistic to just change the organizational structure and the way people work and team responsibilities and team dynamics all at once. Organizations don't want to change, they have natural inertia. So once you do start the process of change, you'll notice friction in lots of different places. So you need to minimize the amount of change at any one time. Right? So now we can go back and look at the problem. So instead of looking at the potential of a technology, we need to look at the friction it causes and how to successfully overcome that friction to adopt new technology within an organization. So put differently, if we know that any change requires us to put in effort to overcome that inertia, we can decide whether the sum of that potential is worth the friction that we need to overcome. So in other words, if we know we want to have a couple of features from Kubernetes, I don't know, the auto scaling part maybe, or the fact that we can now have developers deploy container self-service. So it becomes easier for them to release their application more quickly, right? Instead of waiting for another team, they can now do the releases themselves and do it 20 times a day. That's an actual problem that you're solving because releasing more often has advantages. It has business advantages. So we now understand the kind of the problem that we are trying to solve. So a key part of solving that problem is reducing complexity because complexity causes that friction and inertia, and that kills your chances of successfully adopting a technology. And so often teams don't need all of these features at once right away. Maybe they need them in the future. Look at the amount of tools on this Swiss Army knife. Do you even need them all at once or even at all? Again, the point is, if you make things simpler, if you don't have to if you don't have to look after a full-blown Kubernetes cluster, but instead can get used to continuous releasing, which is, again, a business problem a lot of companies have. They want to stay ahead of the competition. They want to release new features. Making things simpler is almost always the right choice. And so keeping it simple, or KISS, this band, um, it the right choice is almost always a technology that is the simplest and the easiest to implement while still solving the business problem. So choose a simple CI/CD pipeline over a very complex one, right? So that piece of technology could be anything: serverless functions, CI/CD pipeline, a Kubernetes platform, a managed SaaS service. So again, I'm not saying Kubernetes is a bad technology. It can help you solve many problems, but it shouldn't be the default, right? There's other ways of solving your problem that maybe are simpler, easier to implement, easier to be successful with, right? So I'm saying that if you minimize the complexity that causes that organizational friction, you have a much higher chance of success because you take the limits of what your organization can handle into account, right? You cannot change everything within your organization overnight. So we now know that we're solving for organizational friction and inertia, the incapacity to change. And if there's one thing I want to make sure you understand, it's that you're almost always solving an organizational limitation alongside the introduction of a new piece of technology. Business problems are rarely addressed just with technology. And that means we need a minimalist approach to technology. You solve the business problem that you have with the least amount of change technologically. Literally minimize the amount of technology you use to solve your business problem. So if a simpler product solves your problem too, use the simpler problem. And I'll get back to why that's important in terms of future, right? Making simple choices now helps you in the future. It's called technical debt. And I have a slide up about that a little later on. But for now, understand that simple, easy technology that still solves your business problem is preferred over something very complex. And so specifically for Kubernetes, that could mean, I don't know, implementing the core scheduler, but not introduce distributed tracing just yet, or fix that one specific issue you have with a team because they're not able to release to production due to a dependency on an outsourcer or another team. But don't introduce autoscaling just yet because that's still too complex. Or just moving your organization to a bare bones Kubernetes environment so they can get used to running containers in the first place. I mean, who knows? If your organization still doesn't run containers, I wouldn't give them every bell and whistle and autoscaling and tracing and, I don't know, object storage and this and that all at the same time. Just let them use the core scheduler and get accustomed to actually releasing to production first. Right. So all this means you need to solve organizational problems before and while you're introducing new technology, because implementing new technology brings new organizational problems, and you have to solve those existing ones. And I mean, I've been an engineer for a decade too. I know solving organizational problems is much harder than introducing new technology. I know, duh. I mean, that's why I'm giving this talk, right? So at a company I used to work at long ago, we had this saying, don't try to solve organizational issues with technical solutions. And so we lived by this saying. Um, but I feel the last couple of years, the adoption of technology, and specifically Kubernetes in enterprises, pushed this approach to the background a bit too much. So everyone's talking about cloud native Kubernetes, and we're not talking about using technology to solve business problems anymore. So at some point, we kind of flip from solving business problems with technology to using technology that also solves a business problem, right? So we switched it around, which I don't think is a good development because in the end, if you don't know why you're doing something, it is very difficult to figure out your next step. Um, but knowing what business problem you're trying to solve, like I want to be able to release faster because my competition is releasing faster too, and they are taking my market share, for instance, right? That is a business problem. That is something that helps you make the right decisions along the way. So again, this is what making technology choices the right way is all about. Being aware of the organizational limitations and the organizational issues and choosing the right technology to match those limitations. So let's dive into some examples of these organizational issues. So for instance, DevOps teams with Dev and Ops roles, they work great if you develop an app in-house. But what do you do if a commodity application, off-the-shelf application, only needs ops? Do you then still do DevOps? Do you then still run Kubernetes? Does that make sense? Or do you find another way to run that piece of commodity off-the-shelf software? Right? Do you outsource it maybe to a SaaS provider? Do you say to your software vendor, hey, how about you run it for us? Or maybe you figure out a way to duplicate that software into something you do have control over and you can add developers to because you now have a code base to work with. Outsourcing is another big indicator of organizational friction. So the contracts, the financials, project management, they all stand in the way of making the right technology choices the right way. So instead, technology choices often with outsourcing take a backseat to the outsourcer trying to remain relevant, burying themselves in processes, handovers, dependencies. So if you are, if you have an outsourcer that helps you with, I don't know, keeping your e-commerce environment alive or building your software for you, then maybe Kubernetes isn't the right answer for you right now. Maybe the outsourcer will decide, okay, we need Kubernetes, but maybe that's a way for them to make more money and be dependent on, make you dependent on them. Right. So again, outsourcing is a red flag in terms of organization when you are dealing with Kubernetes. The other very obvious one, of course, is traditional non-cross-functional teams, silos of different roles in different teams using tickets and queuing to get things done. So ticketing systems as a communication method don't work, no matter how much technology you throw at it. So if if you're still dependent on a separate ops team to deploy something for you to production, all of the advantages of Kubernetes kind of magically go away, right? But you still have the burden of maintaining Kubernetes in production. So maybe if you still have these teams, Kubernetes isn't the answer for you, but you now also know what you need to do to start working on, actually reaping the benefits of Kubernetes. Do something about the separate ops team. So similarly, if you have a lot of handovers between people in a team or across teams, you won't be able to release quickly and often, regardless of whether you're using Kubernetes or not. And so handovers are often a sign of unhealthy inter-team dependency, or in other words, a too complex organization. You have to have, contact with this person to get that done. You need to call them to figure that out. And so those very complex organizational structures or, very complex hierarchies of different teams and managers and stuff, they often have a historical instead of a actually good reason for organizing that way. So again, you have to break down the way people work and collaborate and how these teams are formed before you can really reap the benefits of Kubernetes. You can build a Kubernetes cluster with all the bells and whistles, but if you still need 20 different teams to get something done, where's the benefit, right? And so let's not forget shared responsibilities across teams, or even within a team. Sometimes they blur the line of who's responsible for what, and that kills the ability to do any technological innovation very quickly. So you need sole or end-to-end exclusive responsibility to fix that problem. And ideally, before you start working with Kubernetes, or at least while you are implementing Kubernetes, if you still have shared responsibilities across a lot of teams after you do Kubernetes, after you implement it, again, you're not enjoying the benefits of Kubernetes. And so having too many stakeholders is very comparable, but again, a surefire way to grind innovation to a halt. And stakeholders, can also be approval gates, tickets that need to be signed off on, change control boards, change advisory boards, control processes. All of those are signs of organizational issues that you need to address before introducing new technology and before introducing Kubernetes. And while not entirely organizational, if you still have inflexible compute environments, um, which many on-prem environments unfortunately are, that does indicate you are, somewhere behind the enterprise IT adoption curve, which means maybe not do bleeding edge technology just yet and go fix those problems. And of course, moving to cloud often means moving to Kubernetes, but it doesn't have to be. I mean, even migrating your stuff from an on-prem data center just into cloud, even without Kubernetes, can already be a very large step. You may need, I don't know, 6 to 9 months to get that done, and then Kubernetes comes after. So in addition, if you're building your own DIY, like do-it-yourself technology platforms, without using any kinds of managed services from the cloud or a service provider, that's also an organizational issue. Someone made the right or wrong choice to build your own platform from scratch. And the issue is that Kubernetes, let's take Kubernetes as an example, right? It's not a core business for the vast majority of companies out there. So if you work for, I don't know, an e-commerce company, or you work in fintech, or you work, I don't know, even in just regular banking, those companies are not in the business of selling and making Kubernetes. Um, they just use the technology to get something done, right? So if you're not using Kubernetes to make money, why the heck are you creating your own platform, right? You're not that special. But often it's because that's what engineers do, not because that's what the business wanted, right? So again, DIY platforms shouldn't be the default choice for running Kubernetes. And if you do see a company running a DIY platform from scratch, that may be a sign of a deeper organizational problem. Like maybe someone wants to do this but doesn't see the issues with it. So another indication of organizational issues are high cycle time and a high lead time for work. And so these both simply mean how much work is in progress, right? So I'm showing the lead time right now, which is from the moment work is ready to start until it is done. And then the smaller version of that is cycle time, how much time is actually needed to get something done. But both of these indicate whether your teams can effectively pick up a piece of work, do it, execute it, and call it done. And if that takes a long time, it may be because of handovers. I don't know, maybe you don't automate a lot, you don't have pipelines. Maybe you need to go for approval with many different people within the company, slowing you down. So regardless of what the blockers and bottlenecks are, it's definitely worth looking at, okay, how much dependencies do we have? How much time does a task take, and why is that the case, right? Because if you optimize for those, you remove a lot of the blockers that were bothering you anyway. And then when you do, go with Kubernetes, implement it in production, start using it, it becomes much easier to be successful with Kubernetes simply because you've already solved the organizational problems behind it. And so, just like too much work in progress, that's another example. Having 20 things at the same time that you need to do indicates you have too much active work in your system, leading to lower quality, manual work, rework, so stuff that you need to do again because it wasn't good enough. And so lots of work in progress is also an indication of the same things, right? Bad automation, toil, bad approval gates. Um, but it can also be caused by past technology choices gone wrong. Like, maybe you chose to go with a cloud that isn't really the thing you need, or maybe you chose a language framework that absolutely doesn't fit your organization. Who knows what it is, right? But too much work in progress is never a good thing. So let's move over to the solution, or the solutions plural, because it's never simple. It's never a single thing, right? So I've been talking now for a while about all of these problems that you can have in your organization. And the difficult message is solving these is not simple at all. It can take months, years, and it will probably take years. But if you know one thing for certain, it's that no amount of technology will fix your organization if it's already broken. So do not introduce Kubernetes if you don't at least, partly have solved these problems, or at least part of these problems already. Um, Kubernetes will not solve these problems that we talked about. You need to solve them anyway, and then do Kubernetes on top of it. Right. So one of the biggest solutions to many of the things that I talked about before is um, thinking about how technology can create on-demand and self-service consumption of infrastructure, of cloud resources. So, think about creating a vending machine model, which isn't new, which isn't sexy anymore. I mean, a lot of companies have already done it. They call it different things. They call it cloud onboarding, or they call it a vending machine, or there's many different names for it, landing zones. But actually having those will help your organization remove dependencies, remove approval gates, remove handovers, remove work in progress. So if there's one thing that I think you should do from a technology perspective, is introduce self-service on demand consumption of infrastructure. Of course, you need Kubernetes for that. And in a lot of cases, Kubernetes absolutely makes sense. But the difference is we're now introducing a solution, self-service, right? A vending machine, and we use Kubernetes to solve that problem, which is different than just, we're going to do Kubernetes now because it solves all of our problems, right? And so services that you can then give to your internal customers is, setting up a cloud tenant, I don't know, a ready-to-go database, or even just a fully deployable production Kubernetes cluster for a given application. Right, so self-service and vending machine models, they cut those inter-team dependencies, they reduce queuing, they reduce handovers, remove human approval gates, they remove ticketing systems, they reduce those lead and cycle times that I talked about. They are really one of the biggest things you can do to solve your organizational problems. So technologies should support this. Use Kubernetes if you have to, if it actually solves a problem that you have, but don't default to it. And then comes the other part that is super difficult, right? The solution is not easy. The solution to all of these organizational problems isn't just a flick of a switch, right? And so figuring out what organizational challenges you actually have is one of the hardest things to find out. One of the things you can do to discover is by doing a value stream mapping. a way of seeing how work flows through an organization. And so, what I like to do is, in addition to mapping out the value streams themselves, you can map out the role technology has in each step, making visible whether you have, an organizational problem or a technical problem, or probably a combination of both. But value stream mappings, or VSMs, help you visualize where you have those dependencies, those handovers, toil, lack of automation, teams that are super busy with high cognitive load. They cannot think about actually improving anything. They're just fighting fires, fighting complexity. Um, and they help find, inefficient team structures, a high lead time, cycle time, and too much work in progress. So often these so-called red items, the things you don't want, are a sign of overly complex past technology choices or organizational inertia that's overdue for some change, right? So a VSM helps you identify all of those red items in your organization. We have an approval gate here, we have a ticketing system there, we're dependent on an outsourcing company to deploy to production. We cannot create, I don't know, a data set for testing automatically, but we need a consultant to help us with that. All of those you can visualize, make visible, and then start working on actually removing those problems. So, diving into the how of fixing this is a bit much for this talk, of course. But the summary is to work on flow, one piece flow, work in progress, dependencies, waste, and handovers, or from going from a we're going to do Kubernetes now and it'll solve all of our problems, go into, yeah, but we need to remove this dependency so that we can release to production quickly. And if we upgrade this little piece of our CI/CD pipeline, then we are able to onboard yet another team to our pipeline, which makes it easier to deploy to production as well, right? So solve a lot of simple, small problems instead of one big one. And so that VSM helps you figuring out how your organization specifically works, allowing you to move away from those, big bang transformation dreams, and removing those reds from your workflows, automating stuff, introducing new technology, while taking the limits of what you can do into account. You'll start to continuously improve, become better at dealing with the organizational friction um, of your organization, and instead kind of have many little happy little incidents and accidents that actually solve your business problems, creating a solid bedrock for adopting newer and more bleeding edge technology. Or, put differently, if you reduce the risk and associated cost by making many small improvements to your organization instead of following some technological pipe dream, Kubernetes is the best, it solves all of our problems. You can start to make small but continuous improvement to your organization and actually start adopting new technology and actually, using the potential of technology to create a cool work culture, create cool solutions. So introducing technology without thinking about its adoption and without thinking about organizational friction will introduce rework. Stuff you need to do better after a little while. So often, this rework or bad quality, missed quality, can take a while to show, but it will show at some point. So not only does it create technical debt, it will also add to the cognitive load later in its life cycle, forcing teams to spend time on fixing things, fighting fires, and doing operational work instead of creating something new, creating new code, new applications, new features, and generally improving stuff. So if you don't account for the maturity of your organization and the problems your organization has, you will create missteps along the way, and you will create future problems that you need to fix later, right? And so on the subject of technical debt, which is it's a super important topic, I think, because it kind of shows um, that if you make the right choice, it'll hunt you and come back in a couple of months' time or a couple of years' time, and you have to fix it anyway, right? So if again, if there's anything that I want you to understand is you can make the wrong choice now and then you have to fix it later, right? So better start on working how to make the right choice from an organizational perspective. And so technical debt is it's important to it's important to understand what it is. It's important to understand how to deal with it. So technical debt is kind of the cost of rework you have to do in the future to keep a system running in the long run. And it can be the result of taking shortcuts in the past, problematic code or shortcuts, fixing things or not fixing things and then coming back to it later. System architectural decisions. Some kind of technological thing that you need to come back to um, somewhere at some point in the future. But here's the thing with tech debt is that if you want to build something new, a new feature, you want to deploy something to production, in a lot of cases there's a little bit of technical debt in your way that you need to fix first, but that technical debt was created months ago or even years ago. And it can be many things, right? It can be, so for instance, let's imagine you have a story where you're gonna double the amount of users in your system. But you can't because you made a choice months ago, years ago, that prevents you from doubling your performance, doubling your load. Right. So now you have to fix that performance issue first before you can even start to think about doubling the amount of users. Right. So another point is, even though technical debt is often seen as a negative thing, it's not necessarily, right? The shortcuts you take now might speed up your go to market, giving you a first mover advantage over your competitor. But balancing technical debt, right? You can't have too much, you can't have too little, but balancing it isn't the full story, because preventing that in the first place by choosing something simple that still fits your requirements prevents you from having to fix complexity and debt later, while still giving you the leverage and the first mover advantage, right? So technical debt is great to imagine, okay, but we need to make the right decision so that we can move forward now, not create too many problems in the future. But there's also a notion of not creating debt at all if you don't need to, right? In many cases, it's unavoidable, but in some cases you can actually avoid creating debt. And that's what I mean by make technology choices and make them simple so that you don't create that debt at all. And then lastly, um, create a mindset where people leave code, systems, teams, processes, and culture in a better state than they found it, right? So otherwise known as the Boy Scout rule. If you start to work on a piece of code and you see something that's, a little bit spaghetti, it's ugly, it doesn't really work anymore, but it's not necessarily the thing you're supposed to work on right now for your story, then go ahead and fix it anyway if it's, maybe 30 minutes to an hour of work. That way, you leave the system in a better state than it was, and you've removed a little bit of technical debt without anyone knowing, without anyone noticing. And so, doing this, implementing the Boy Scout rule is actually a way of continuously fixing little problems that you have right now. And that helps to remove organizational problems, organizational challenges. And what I really mean by this is training people to recognize functional versus non-functional requirements. So non-functionals are almost always more important than functional requirements. And I know that's a dangerous thing for me to say, but quality trumps features every time. Having a system that works really well is of high quality, but only does a single thing is preferred over having something that doesn't work half the time but has 20 different features, right? So simple, secure, easy, manageable, performant, scalable, maintainable, they are all more important than adding feature X and Y. They help prevent technical debt. And so the other part is that if you think about the organizational issues that you may have, simpler technology helps you break down a couple of those issues, and specifically hero complex. Right. So hero complex is the notion where you make a couple of people responsible for a solution. Right. They know everything about a given system. They know how to fix it if it goes down. They know how to deploy to production, and no one else does. And if you choose complex technology and don't implement it the right way, you create a dependency on those individuals, on those select few that have mastered that complexity. And so if you keep technology choices simple, it means it's easier for more people to grasp a piece of technology, to fix it if it's broken, to, I don't know, release to production, to do, to analyze traces, to, I don't know, there are so many examples, but you get what I trying to say. And so we're almost there. Hopefully, you start recognizing that the organization you're introducing technology to has to be ready for that technology. That's not always the case. And so, if that's the case, introducing new technology will not solve much for those organizations, even if it takes a while for those problems to surface after start using the technology. So I hope I helped you realize that technology is only a small part of successful cloud native organizations, and that successful organizations are those that solve their own problems, inertia, friction, with organizational improvements and not technology advancements. Easy, right? And I mean, who am I kidding? Of course you need Kubernetes. Don't listen to me. Forget everything I said. But for now, thank you for listening. Feel free to ask a question in the Q&A. Hit me up on Twitter, or join me, of course, in a Zoom call right after this.
Thank you, Joep. That was a very educational speech. At least I could say that. And let me also remind that we have two chats which are integrated, one with another. One is in your application, and another is just in Telegram. In any of those chats, please put your questions to Joep, and we still have some time, so we probably will answer a couple of questions here in the studio, and then we will switch to Zoom, where we can continue for unlimited time for the following follow-up discussion. So let me quickly check if we have any questions. I don't have. I don't see anything there yet, but I do have a couple of my own. And first, given that we have a lot of engineers coming to our conference here, and most probably the takeaway for these people from your talk will be to help them to interact with their colleagues and maybe bosses when the discussion comes to the question, or maybe even to imperative, of transferring whatever they have now to the new, fancy, modern, youthful, joyful, and a lot of other nice wordings, Kubernetes platform. So everybody is excited. The boss is excited. The junior engineers are excited. And hopefully there will be someone who listens to you.
Hopefully. I mean,
yes.
if only one person even listens.
Yes, in the whole organization, then we have a hope. But my question is this. When such a person happens to be tomorrow or next week, when their boss comes to them saying, okay, we need to throw away what we were doing and migrate to Kubernetes, what should they answer or maybe ask to their
Right.
boss? Can you just enumerate 1 to 3 things
Oh, so
as an engineer?
yes. So I mean, that's a wildly specific question. So it depends, right? I mean, I used to be a CTO, I used to be an architect, I used to be an engineer. The question is always, it depends. So I'm obligated to give that answer, right? Um, but honestly, the question that the first question I think that you should ask your boss is why? Why are we implementing Kubernetes? What business problem is it actually solving? Because Kubernetes is so many different things, it is such a broad set of technologies and features that if you don't know why you're doing something, it becomes super difficult to be successful with it. So, for instance, maybe you're doing Kubernetes and your boss thinks you're doing it because it gets you, I don't know, unlimited auto scaling or some bullshit. Um, but maybe you think it's because it's easier to deploy containers to production, which makes it easier to release, quickly and often. Um, so actually agreeing on why you do something, why are we going to do Kubernetes, is going to save you so much pain later. Because then is it because of the auto scaling or is it because of the fancy CI/CD pipelines? I mean, who knows? But make sure that you understand why you're doing something. And Kubernetes is not a why. So if someone says, yeah, we're doing Kubernetes and they don't have an answer to the why, that's a red flag. I mean, that's honestly where you as an engineer can say, okay, but hold on, explain to me why, and then dive into that.
Okay. Thank you. Thank you very much. Another question, and once again, given that we have some time, I'm pretty much sure that you have a plentiful of real stories when you were helping your clients maybe to migrate to Kubernetes. But can you tell us the story, well, without any names, when you talked your client out of migrating to
Oh,
Kubernetes?
okay. So that's a good one. And I have a good story about a customer, a client that I talked out of doing it. So this was a company that did not build their own software at all. Literally,
Mm-hmm.
they just took a piece of software from a vendor, VMware, Microsoft, Citrix, some kind of random business application, right? And then they would package that up into a solution, into a service, and deliver it to the customer.
Mm-hmm.
And they went mad on Kubernetes. We have to do Kubernetes. It's the next best thing, blah, blah, blah. And so I asked them, okay, but why? Why are you doing Kubernetes? Because it's the new generation of new and hip and cool and insert positive word here. But what they forgot was that running something in Kubernetes really only makes sense if you have a pipeline of stuff going from code on the one hand to production on the other, right?
And they
But
were and they were installing stuff onto their client's infrastructure
yes,
somehow. Okay.
yeah. And so it doesn't make sense for them to run Kubernetes at all. Like, why? You're now just replacing, the VMware hypervisor with a a different scheduler that runs containers instead of VMs, and that's the only thing you're going to do with it. You're not even going to, I don't know, implement a CI/CD pipeline, because how are you going to do a CI/CD pipeline if a third party delivers you the software, the binary to deploy, right? It doesn't make sense at all. So I talked them out of it. And this is, I don't know, 6 years ago, maybe 5 years ago, quite a while ago. And to my knowledge, they still don't run Kubernetes because they still don't have the use case for it, right?
And still
Um,
making money.
and they still exist. It's still a cool company. Still, a lot of friends work there. They still have a reason to exist, but Kubernetes doesn't have a reason to exist within their company.
Oh, no, that's great. Uh, In this case, I think this would be a good point to proceed to the discussion room. And once again, Joep, thank you very much for everybody who was attending this talk. Thank you very much as well. And please don't leave away. Follow with us to the discussion room, where we will continue speaking to you, Piscaer. Once again, thank you very much, and we are proceeding into the discussion room now.
Thanks, everyone.